All right, today what we're going to do is work on ellipse and hyperbolas, ellipses and hyperbolas. First we'll start with the ellipse. Now the ellipse is another one of our conic sections that is created when a plane intersects a cone. The standard form for an ellipse is very different from a circle. In a circle, you just want to complete the square, and then whatever number's left on the right-hand side of the equal sign is the square of your radius. Well, for an ellipse and a hyperbola, we don't want a number over there. We actually want it to say equals 1. That's going to be a key part of our standard form. So it's x minus h squared over a squared plus y minus k squared over b squared equals 1. Now, let's not get too worked up about what a squared is and what b squared is. It's just that whatever this value is underneath x is a distance from the center to the end point along the x-axis of my ellipse. So basically, h and k are my center, and I'm going to move the square root of this number, or a, along the x to get to the ends of my ellipse or oval. B is just how far I'm going to move along the y to get to my endpoints of the vertical axis of the oval. We'll get into that more as I show you a couple examples. All right, I'm giving you one that's already in standard form to start off with. These are the 4 major pieces that I need to know to answer questions about my ellipse. So let's first look at the center. The center of my ellipse should be one of the easier answers to get. We're going to do the opposite. So -4, comma, +5 would be my center. Now, I want the endpoints of the major and minor axis. As I just mentioned, the square root of this number, this is a squared, so the square root would be 7. So I'm going to move 7 along the x, left and right, to get to the endpoints of my horizontal axis. I'm going to move 4, the square root of 16, up and down along the y to get the endpoints of my vertical axis. Question is, which one's the major axis and which one's the minor axis? Because an ellipse could look like this, or it could look like this. Okay, so we're not sure which way it is. And the words are very indicative of the answer to that question. Major is bigger, minor is smaller. It's that simple. Which one? And there goes my pen. Wait, catch it. Okay, sorry. Major is bigger. 49 is bigger than 16. So I'm going to take the square root of 49 and get 7, move it along the x or horizontal axis, and because it's bigger, that's under the major axis. So what I'm going to do is find the 2 endpoints. Now, where am I moving from? I'm moving from the center. I start at the center, and I'm going to move 7 to the left and 7 to the right to get my major axis endpoints. 7 along the x. Well, if I'm moving along the x, the y coordinate's not changing at all. So I'm just going to put the 5 back where it belongs. And when I move along the x, I'm going to add 7 when I move to the right and subtract 7 when I move to the left. So if I subtract 7, I'm at -11. And if I add 7, I'm at +3. And there are the endpoints of my major axis. Now, you can always draw this on a graph. And when you draw the center, and then when you count 7 spaces to the left and 7 to the right, you should get these same vertices or endpoints. All right, my minor axis, since 16 is smaller than 49, this represents my minor axis. I am moving the square root of 16, 4, along the y coordinate from the center. So I go back to the center, and I'm looking for the endpoints of my minor axis. And by the way, since the major axis is along the x, I know my ellipse is going to look more like this. That's what it's going to look like if I graph it, as opposed to one that's longer vertically. I'm going to add and subtract 4 from the y coordinate. So I'm going to leave the x coordinate alone, and I'm going to add and subtract 4 from the 5. So when I subtract 4, I get 1, and when I add 4, I get 9. And again, you could put that on a graph, and you could just count, and you should get those exact same coordinates. Now, there is no rule that says which one has to come first and which one has to come second. It is important which ones are the major axis endpoints and which ones are the minor axis endpoints, but it doesn't matter if I wrote one of these first and one of these second. All right, now the foci. I've put the formula for the foci at the bottom here. It just basically is saying to take these two values and subtract them. Don't take the square root yet, okay? Order of operations says I take a squared, which is 49. C squared is equal to 49 minus 16. Now again, I don't want to get hung up on which one's a squared and which one is b squared. You want these to subtract and give you a positive value. Okay, we can't take the square root of a negative. So I wouldn't take 16 minus 49. So it doesn't matter which one's first or second or which one's a or b. You're just going to subtract them and get a positive answer. Then, and only then, take the square root. So 49 minus 16 is 33. So that means C is the square root of 33. Just for the sake of cleaning this up a little bit, there we go. I have to move the square root of 33. Well, which way? I'm going to go back and draw the 1 because I know that it is shaped sort of like this. I have to move to get to the foci along the major axis. The major axis is along the x-coordinate. So what I'm going to do is, to get to the endpoints, I added and subtracted 7. But to get to the foci, I'm going to add and subtract the square root of 33. So I'm going to take the, again, I'm going to leave the y-coordinate alone, okay, because I'm moving along the x, along the major axis. And I'm going to take that negative 4, and I'm going to add and subtract the square root of 33. And you know what? I don't need to separate it. Now I wouldn't, oh, I just wrote a 35, didn't I? Okay. When I added and subtracted 7, I can figure that out. What is negative 4 plus 7 and what is negative 4 minus 7? And that's how I got these values. But I don't know what negative 4 plus the square root of 33 is. So there's nothing left for me to do. I can't simplify that at all. So I'm going to just leave it as negative 4 plus or minus square root of 33, comma 5. And those are the coordinates of my two focal points. All right, so let's try one where you don't have it already in standard form. So you get to do the extra work, yay, of putting it in standard form. So the first step is to get the x together with the x squared, and get the y squared together with the y, and move C. Okay, from the x's, I need to factor out the 9 before I can complete the square. You cannot start taking half of, oh goodness, 54 and squaring it. It's going to be a ridiculous number. You have to factor out the 9 first. X squared plus 6x. And then I don't have anything to factor out of the y squared, so yay. I'm just going to leave it. But I'll leave a space so I still am going to have to complete the square. I just don't have to factor anything out of it. Okay, so I'll use green. I'll use black. I'm going to complete the square. I take half of 6, which is 3, square it and get 9. And then I have to add the same thing over here. Well, here's my question. Did I really add 9 on the left side? I added 9, which is inside a parenthesis, being multiplied by another 9. So technically, I added 81. So to be fair and balanced, I have to add 81 to the other side. Okay, to complete the square, I take half of 2, which is 1, square it, and I get 1. Well, I'm going to add 1 to the other side, just to be fair. Okay, so let's clean this up. I have a 9, and I'm going to rewrite this as x plus 3 squared. And that's how what this factors into. And then over here, I don't have a number on the outside, but it does factor into y plus 1 squared equals 73 plus 81 is 8, plus 1 is 9. And then it's not quite in standard form yet because it has to say equals 1. So I'm going to divide everything by 9 so that this will say equals 1. 9 over 9 will cancel. Now, just to be on the safe side, when it cancels, technically what you're doing is 9 goes into itself once, and it goes into itself once. So I'm going to leave it as this, just so it looks more like my standard form. And then there's nothing to reduce here. And I now have standard form. And also now I'm running out of room, so I'll try to see if I can get my answers in here as best I can. All right, the first one's the easiest. That is the center. And that is going to be at -3, -1. All right? Now, which way does my ellipse, which direction is the major axis of my ellipse? Is it a horizontal major axis or a vertical major axis? Remember, it's the one that's larger. Which one is larger? Oh, the 9 is larger. So that means this one is going to look more like this. All right? So, for the major axis, I'm going to have to add and subtract 3, square root of 9, from the y coordinate, right? So I'm going to have to go up 3 and down 3. So when I move the y coordinate, I'm not changing the x coordinate. So I'm going to go ahead and write my x coordinate in here. And then I'm going to subtract 3, which is -4, and add 3, which is 2, from the y coordinate. For the minor axis, I'm going to move along the horizontal axis. I'm going to move left and right. So I'm basically adding and subtracting how much? 1 from the x coordinate. So my y coordinate in this case is going to stay. I'm going to subtract 1, which gives me -4, and add 1, which is -2. And these are the endpoints of my minor axis. That would be these points right here. All right, and then finally, my foci. Well, let's see. I want to take a squared minus b squared. 9 minus 1 is 8. Let's see. I will write that. I'll use green or black over here. Okay. C squared is 9 minus 1. C squared is 8. C is the square root of 8, but I can't leave it like that. I have to simplify it. That reduces, or sorry, simplifies to 2 square roots of 2. 8 is 2 times 2 times 2. I have 2 of a kind. I can take them out and put them on the outside. So I'm going to add and subtract 2 square roots of 2 from which coordinate? Remember, the foci are along the major axis, so that means I have to add and subtract 2 square roots of 2 from the y coordinate. Let's see, so here's my y coordinate. So I'm going to leave the x coordinate alone and write a -3. And then I'm going to take my -1, add and subtract 2 square roots of 2. And I'm done. And there's an ellipse. All right. I think we've covered everything for the ellipse. Great, thanks.